Ashish, Prasad, Namrata, and Sumit. Okay, so Ashish, I am going to start from you. So
Yes, sir.
just tell me about your your education project and the courses which you have completed. Okay,
Sir,
in brief.
should I start? Sir, should I start the introduction part?
No. Just tell me about your PG or UG. You have done PG or UG and your stream. After that, what are relevant courses you have completed and about your projects. Only that part.
Oh, yes, sir. Sir, I am an undergraduate student, fourth year, BTech,
Okay.
and at an IT Sikkim. And yes, sir. Sir, I have done projects on the FIFO, synchronous and asynchronous both, and the AVP, and sir, the binary to gray encoding.
APB. Okay. Protocol.
Yes,
And
sir.
other. And
No, sir, but just only this. And sir, I learned about the basic digital electronics, the Verilog coding, and sir, some the low power technique and SCDC techniques. These things.
low power CDC. Okay. Okay. Then. Okay. And Prasad, tell me about yourself.
Yes, sir.
Yeah.
My name is Sunko Prasad. I am from Hyderabad. I did my graduate in the 2021, and I went through
graduation only graduation BTech.
Yes, graduated.
Okay.
I was graduated. Then after I was trained through my Silicon. There I got the job opportunity in the Soft Nordics. There I did 10 months of in the experience in the verification role. I did there in the my project details is about I2C soft IP I2C basics. It is among APB and I2C.
Have you designing of I2C or designing and verification both?
Verification of I2C, UVM based.
UVM based verification of I2C.
Yes,
okay.
yes.
Okay, and other than that?
Then I did protocols on APB, HB2,
Yeah.
and the I2C also, and the basics of HB also.
You have only completed the theory of APB-HB, or you have done the verification using UVM or system verilog?
UVM, yes, using UVM only.
Okay. And okay, it is relevant for you.
And then after due to layoff.
Oh yeah, okay.
Yes, due to layoff, I lost my job recently.
Okay.
So I approached here.
In which courses you are comfortable, like digital verilog, system verilog, UVM, CDC,
system verilog, UVM right now, because I have gone through 10 months. I've gone through the UVM, and after 2 days I will go through digital base. Yes, sir.
Okay, system verilog, and digital. Okay, so it is
UVM.
Okay, UVM. I know. Okay, and
UVM.
Hello, Namrata.
Hello, sir.
Yeah, tell me about yourself.
Good evening, sir. This is Namrata. I'm currently pursuing my BTech final year from CVR College of Engineering, and my specialization is EEE. I have done projects.
EEE.
Yes, sir.
Okay. Where is this college? The location of college? Hyderabad. Okay. So continue, please.
I have done projects in Verilog, STA, PTO.
Verilog and STA. Okay, you have completed your project in Verilog and STM. Okay, and could you spell the Could you tell me the name of project?
Verilog.
Can you tell me okay, only you have completed the theory part of Verilog.
Yes.
Okay, theory part of Verilog. Okay. And other than that, and STA, theory STA. And anything else?
Currently doing system Verilog projects. Almost just completed.
Okay. System Verilog. Okay. Like you haven't completed any project, just gone through, completed the theory of these two parts. Okay, hello Sumit.
Hello, sir.
Yeah, actually your video is not visible. If you are comfortable,
yes,
then you can
yes.
switch
Sure.
up.
Sure, sir.
Okay.
Hello, sir. My name is Somesh Sharma,
Yeah,
and
sure.
I have completed my bachelor's from SRM University, Delhi. And right now,
SRM Delhi.
currently I am yes sir. Currently I am pursuing my master's from Manipal University, Jaipur. In terms of projects, I have done projects on Verilog. It was like encryption decryption type of project based on a research paper. So I have done that.
In,
And course
encryption of what?
on encryption or decryption of data.
Encryption and decryption of data. Okay. And other time?
Text message basically.
Okay.
What's the?
And you have
And
like
sir,
this is the one project you have. Okay. Yeah.
yes sir.
Have
And
you done
other
any
projects I
other
have done
project?
are
Yeah.
in embedded. Those are in embedded.
Yeah. Just tell me. No issue.
Okay, I have made 3D printers, drones, and robots in the field of
Which
embedded.
language you have used? Like which
C,
language
sir,
you have
C
used?
hash, embedded C.
Embedded C, no? Okay. And
Yes, sir.
okay. Other than that, you have completed comfortable any language, programming language, and related coursework.
Yes. Apart from that, I have knowledge of Python.
Python
Yes,
and
and Verilog and System Verilog.
Verilog and
System
system
Verilog.
Verilog. Okay.
And
Okay.
I have completed my modules of digital, System
Okay.
Verilog, Verilog, and protocols, AMBA protocol,
Hmm.
and AHP protocols. All these protocols I have completed.
Okay. So okay. So I'm going to start from Sumit. You just tell me that
Okay, sir.
what is the meaning of Little Indian and Big Indian?
What is the difference between
Little Indian and Big Indian.
Little Indian? No idea, sir.
No idea. You have. Okay. So okay. So tell me about like FSM. You know the finite state machine. What is?
Yes, sir.
Yeah.
Yes, sir. Finite state
Okay.
machine are
Just do one thing.
Yes,
Actually, I take a pen and paper and tell me the difference between the Mealy machine and Moore machine. Write at least 5 points. Okay. And yeah. When you have completed, just I'm writing my contact number in the chat. Just take the pic
Okay.
and send me.
Okay, sure, sir.
Okay. This is for everyone. Okay.
Okay.
Yeah. Okay. And and hello Namrata.
Hello, sir.
Yeah, I can see you have completed the system Verilog, STA, and theory part of Verilog. Okay. Can you write one like a Verilog program? Okay, Verilog code for shift register. Okay. Okay, actually, no, not that one. I'm going to give you some simple thing. Okay, just wait 1 minute. 1 minute. 1 minute. Okay. I have write one question. Okay.
Yes.
In chat box, you just see this question and try to implement that hardware of that logic. Okay, just you have to tell me that what is the hardware of this logic. Okay, always at the rate pauses of clock, then begin and end block, or age assigned to q1 and q1 is assigned to q2. Okay, just think q1 and q2 like the output of a flip flop. Okay, just you have to make the connection. You have two flip flop f1 f2 and you have to make the connection. Okay, and what is, just take a pen paper and do it. Hello Prasad. Hello.
Hello, sir. Hi, sir.
Yeah, actually yeah. Okay, so Prasad, you have completed project on system Verilog, na? And UVM.
UVM basically.
Okay, yeah. Can you tell me the difference between polymorphism and abstraction?
For polymorphism abstraction, right?
Yeah.
So here polymorphism means, okay. Can I say or written?
Okay, actually write an example. Okay,
Okay.
r- write an example of polymorphism and
Okay.
abstraction. What these two things? Okay. So I want to know that.
Okay, fine.
Okay, no, okay. Leave abstraction, inheritance, and polymorphism. Okay, take an example
Yeah, sure.
and using
Okay.
you use system Verilog and give me a best example, and after that you have to explain me that the example which you have taken. Okay,
Yeah,
what
sure.
is the inheritance and polymorphism? Okay.
Okay.
Hello, Ashish.
Sure. Okay.
Yes, sir.
Yeah, yeah. Pick a pen. For Prasad, you take a pen and paper and write on paper. Okay.
Yes, sir. Yes, sir. 2 minutes.
Yeah, yeah. Hello, Ashish.
Yes, sir.
Yeah. Okay. I'm giving you one question in chat box. Okay.
Yes, sir.
You have
Yes, sir.
just okay.
Hmm.
Yeah. Just see. And this one. Okay. So
Yes, sir.
always at the red pauses, begin and end block. Q1 is assigned to Q2 and A is assigned to Q1, then end. Okay. And Q1 and Q2 is the output of flip-flop. So you have to draw the hardware, like how this flip-flop is connected. Okay.
Okay,
Take
sir.
a pen paper and give me answer. Okay. Have anyone sent me the answer? Okay, didn't send anyone. Hello, Sunit.
Hello, sir.
Yeah. I think I have given enough time for you, so you have just to mention those points.
Okay.
Yeah.
So should I send you the picture?
Yeah, you can send me the picture and also you can tell me orally if you want.
Okay.
Yeah, send me the picture is like I think a good way to communicate. I can see
Okay.
whatever you want.
Yeah. Yes. Just let me see your number first.
Sir, should I also send the in
Yeah,
WhatsApp?
yeah. You have to send in person.
Okay, sir. Sir, I'm sending.
Hello, Namrata.
Hello, sir.
Yeah. What happened? This is very confusing, or it's a very simple thing. I think.
Sir, polymorphism and inheritance both, right?
Yeah. Polymorphism and inheritance.
Okay.
Can you like you have to able, are you able to write the logic for polymorphism and inheritance like
Yes, sir. I have WhatsApped it.
okay you have sent me now.
Yes.
Number of states are n, number of its second. Okay, first point is it's absolutely wrong. The number of states are n and the number of states are n plus 1. Okay, this is 100% wrong. I am very pretty much sure. Okay, the output second is your okay. And transition. Okay, like you are able to teach me only 2 points in million Moore machine, and which is very basic from digital electronics. Okay, so your first point is wrong, and I will clear it later. Okay, so Sumit, other than that, Okay, I want to ask you one question that you know.
Yes, sir.
1 minute. Just wait 1 minute. So I have written a logic in chat box. Okay.
Yes, sir.
So you just take always at the rate pause or close and begin and end block. Q1 is assigned to Q2
Okay.
non-blocking. Okay. And
Okay.
A1 is assigned to Q1. Okay. This is
Hmm.
blocking. So you have to
Okay.
write, this is the Q1 and Q2 are output of flip-flop. Okay. So
Hmm.
you have to like draw a hardware module for this. Okay. How
Okay.
flip-flop are connected.
Okay.
Okay. Yeah. And Asis, you have sent this, no?
Yes, sir. Sir, but one thing like I would like to say, sir.
Yeah.
In question, sir, the blocking assignment was used. Sir,
No, no, no. Whatever I'm using, I'm just asking as an interview. Okay. This is
okay,
not. Mm, yeah, just don't worry about that. I know whatever I'm written here.
okay. Oh yes, sir.
You don't need to worry about it. So okay. So see, if what happen if I will use first like this one, I am sending to you. Just wait.
Yes, sir. I
What?
was WhatsApp the.
Yeah, yeah, I know. Asis, if I send this one, then how the diagram will be like? What are the changes are in the diagram?
Sir.
So who is send this?
Sir, sir, the picture I sent you, sir, this is for the new code, and sir, the previous code will have a Q2 is equal to Q1, and the assignment will be first done.
Who told you?
Sir, Asis.
Asis. No, no, just draw it. I will take it. I will see it.
Okay. Sir.
Just draw it. Yeah, Sumit, you have sent me for this logic, no?
Yes, sir. Yes.
Okay, and last one. Let me check. Okay. So there you have to draw the diagram. Okay. How can you connect like Q2? Is it right? Q2 is as Q2 is the output of flip flop. How can you connect at input? Hello, hello, Sumit.
Yes, sir. Yes, sir. Q2 is the output.
Yeah, yeah. Q2 is the output. So how can you connect at input this? Q2 is the output, na? So how? Why are you putting at input of flip flop 2 as Q1 as Q2 is as input? I'm able to like I'm my voice is audible to you.
Yes, sir. Yes, sir.
Hello, Namrata. If you
Yes.
are not able to answer this, then we can switch to the next question if you want.
Next question.
Okay, okay.
Sir, can I get answer?
Yeah, whatever answer you have, just you have to send me. There is no need to worry about it. Yeah. Actually, I want you to just tell me about the what is the clock to Q delay, Namrata.
Sir,
What is the clock to Q delay in STA? What is the clock to Q delay?
it is referred as the
referred as what?
Clock.
What happened?
Clock delay.
Hmm?
Clock delay.
Yeah, clock delay. So what is the clock to queue delay? I'm asking, like, what is the clock to queue delay? Okay, so I'm just tell me the difference between synchronous and asynchronous circuit. What is the synchronous and asynchronous?
Synchronous.
Yeah.
Asynchronous is a non-continuous.
What?
Non-continuous.
Synchronous? Okay, non-continuous.
Synchronous is a continuous, and in latches we use asynchronous and synchronous both.
Hmm.
Mm,
Okay. So I leave it. Can you like make a circuit for mod 5 counter? Okay, Namrata.
yes, sir.
Yeah, make a circuit for mod 5 counter. Okay, so give me the code for the polymorphism. Okay. Hello.
Inheritance I'm writing, sir.
Okay. Return for inheritance. Yeah. Just complete it, then we will discuss questions. Yeah.
Yeah.
Ashish, have you come able to do it? Do that one also? Okay, Sumit.
Yes, sir. I'm doing.
Yeah.
Yes, sir.
You are doing, or you have done already?
So which one? Which one, sir? This code ka diagram?
Yeah, code ka diagram.
Okay, please.
Hello, Ashish.
Yes, sir.
Yeah, okay. Just let's discuss some topic. Okay. So, what is the CDC?
Sir, CDC stands for class domain crossing. Sir, actually, it means suppose we are transmitting some data over different module blocks which are working on different frequencies. Then this is called as class domain crossing.
So we have data and we have the different IPs which is running at different clock frequencies. So what happens when we are sending the data?
Sir, actually, when we send the data, then suppose the writing speed is fast and reading speed is low. Then since writing speed is fast, so there may be a cause of the data loss. Or suppose we are sending some data and just on the clock edge it get sampled, so there is a chance of the metastability as well, which is the major problem in CDC.
So what is metastability?
Sir, metastability is a state on which the signal value lies between zeros and one and is not definite to some value.
Okay.
It can be any value between zero.
Okay. So can we remove the metastability from circuit?
No, sir. We cannot remove. We just reduce the chance of metastability.
Okay. So how can we reduce the chance of metastability?
Sir, there are different techniques. Like we can use the synchronizer circuits to reduce it, and the sum of these synchronizers and FIFO we can use to reduce it.
Okay,
Reduce the chance.
So which type of synchronizer you are prefer to use?
Sir,
Yeah. Basically,
sir, it depends.
No. If generally we will, which type of synchronizer we will prefer? Generally, in terms of textbook which we have written, just to,
Uh,
which you have read from your textbook.
yes, sir. So like according to me, it depends upon the needs. Suppose if we are sending some
Okay.
simple one bit data.
So what is the two flop synchronizer?
Yes, sir. Sir, two flop synchronizer is just used to send data of single bit. It consists of two deep flip flop and working on the.
I want you to just draw the like the that diagram which consists the delay and metastability and data in, data out. Okay.
Okay, sir.
Okay,
Sir,
draw that.
sir, the block diagram and the timing diagram both.
Only timing diagram. Block diagram is not necessary. What?
Okay, sir.
Yeah. So Sumit, you have sent me this for the last one. Na? Okay, it's okay. So
Yes, sir.
okay, Sumit, I'm coming to you. Okay. So just tell me what is the difference between blocking and non-blocking assignment?
So blocking, non-blocking assignment. In blocking assignment, the value will trigger only at, for example, like you have written in this code, there are two codes. In this, the value will only stop, for example, in blocking Q2 when it matches the value of Q2. But in non-blocking, the value will start from initial to the final point, like we can see in the second code.
There. What is the difference between blocking assignment and non-blocking assignment? Okay. So okay. Tell me what is the difference between initial and always block?
Initial and
Always block.
always block. In always block, we can assign for which condition the system will start or trigger. But in initial, we generalize the starting of the code.
Okay. So you know about AMBA protocol.
Yes, sir.
Okay. So what AMBA does, like what AMBA is doing in circuit, like what is the specification, AMBA stand for what, and why we need AMBA, and just
The
give me brief.
AMBA is a protocol which is used to communicate between the different systems. There are two
systems.
Yes,
Systems, no?
systems or modules, you can say.
Which okay, I have one module like mobile and one module of laptop, so I can use AMBA protocol here.
So if you have hard wiring between them.
So hard wiring, I can use a hard wiring. Okay.
Through buses, AMBA deal in terms of buses.
Okay, so why are you saying like systems?
So basically modules, like on SOC chip, protocol will work to integrate the different modules or basically systems together.
Okay. So we have AHP and APB and AXI. So what is the difference between these three? Just write 5 points of everyone and send me. Okay.
Okay, sir.
Okay. Hello, Prasad. Hello, Prasad.
Yes, sir. I'm clicking the inheritance. One second.
So tell me in general, like what is the polymorphism and inheritance?
Just 1 second. I'm pinging the page. I will explain by code.
Okay, Namrata. It's okay. So can you make a circuit like if I have clock frequency f, then how can I get the clock frequency of f by 2?
Sir?
Make a circuit where I give input as frequency f, okay? Okay, so if I want output as frequency of f by 2, then which circuit I have used, just draw that circuit.
Okay.
Okay, you can verify. Yeah, okay, Prasad, can you tell me what is the difference between inheritance and polymorphism?
Yes, sir.
Yeah.
I would say polymorphism here. Sorry, polymorphism means poly means like many. Morphism
Yeah.
means like having the many methods. We can say like by making the same functional names, we can access the properties of uh, parents properties and methods. Right? We can access by making the functions as a virtual, putting as a virtual keyword.
Okay.
And whereas like
Inheritance.
inheritance is like modifying the existence code, means in the sense the parent cannot access the properties of child, but child can access the properties of parent.
Okay, if I want some, so if I want to add some extra feature in child classes,
Child
okay,
classes.
so how can we do that?
We can by throw like we have like keywords like super keyword. We have,
Okay, okay. So how if I use super keyword, then these changes are going to refer in the parent classes or not?
but through by globally we have to create in the parent, right. So from if we have to access the child, we have to go through super keyword. There we can get the properties of like parents. If we have to by making the casting also, we can get the like dollar cost of child child with the parent, then we can get the accessibility.
Okay, okay, okay.
Hello, am I getting?
Yeah, you are audible. So what is the difference between RAND and RAND-C?
Ranch is like cyclic, means in the sense if, like if we have this randomization of 0 to 5, like bit of 0 to in the sense of 0 to 4 in the hive there is no cyclic, there is no repeated. Like after the completion of 0 bits only it will be generation, whereas in the rand it can be like repetition will be happen within the range
Okay, okay.
while in the
So
randomization.
okay. I understand. So what is the difference between task and function?
Task is, see,
Yeah.
task is a lot time consuming, whereas a function cannot the time consuming. It will be like zero simulation. Function will be executed in the zero simulation time, where a task will be like it will be time consuming.
Okay. So give me an example of task and function. Just a very small example. Write only the logic for task and function, not whole code. Just write the logic of task and function, like in 2 3 lines and 2 3 lines, not more than that. Okay.
Yeah,
Yeah.
like I can go through like some phase like threads like 4gen within the threads.
No, just simple one.
Just simplify.
Okay.
Hello,
Uh,
excuse me, sir.
yeah.
Yes, sir. I don't know the answer. I only know the full form of APB, AHB, and AXI. So I can't write the 5 points.
Okay. So, okay, this is my sincere suggestion. Okay, so whatever
Yes,
you
sir.
have mentioned in your resume, you have to know each and everything about it. Okay.
Yes, sure, sir.
Yeah. Okay. So if you do like that, then they will not going to. It is going to create a very bad impact of yours. Okay.
Yes,
So you have completed the system very long, na?
yes, sir.
Yeah. Okay, can you give me how is the test bench is created in system very like, and what is the difference between semaphores and mailbox?
SEMA mailbox and
Semaphores.
semaphores.
Yeah.
So actually, semaphores is the system value of faculty have not taught yet, but mailbox, yeah, I know about mailbox.
Okay. They didn't tell you that like, what is the semaphore? Okay,
No,
no issue.
uh,
No issue. I believe that they taught you, but maybe you missed that part.
okay.
Okay. So tell me about the mailbox that.
Mailbox is a virtual kind of thing in which the data will be stored before transferring it to the other module.
Okay.
For example, a data will generated by a generator, and for going it in the driver, it will first be stored in the mailbox.
Okay. So why we are using mailbox? What is the need of mailbox?
What is the need of mailbox? So to temporarily store the data, basically.
Mailbox is used for the storage purpose.
Yes, sir.
I don't think like that. 1 minute. Yeah, Ashish, just check your WhatsApp. Okay. So
Yes, sir.
it's okay. So okay, can you draw a circuit diagram like which have the frequency of f by 3? If I'm giving input
Yes.
as f, then it gives the frequency f by 3.
Okay, sir.
Okay.
Sir,
Yeah. Yeah, Namrata.
I guess I need more preparations.
Yeah, no issue, and just focus on the basic and start from the basic. Okay.
Yes.
Okay. And in which year you are?
Sir,
In which year are you studying right now? You are in final year BTech, no?
yes, sir.
Okay. So, like, they have started your placement already have completed, or the placement is left in your college?
From college, I'm.
You are not preparing for college. You are trying to for offline, off-campus placement, no?
Yes, yes, sir.
So no need to hurry. Okay. Are you comfortable in C programming?
I know basics, sir.
Okay. Basic C programming. Okay. Can you write a code for me and for the generated table of 2?
Mm,
Can you write a code for generate a table of 2?
Table for 2.
Yeah. Just use for block like for loop. Give I from 0 to 10 and write the logic of that. Very simple one I'm giving you. Just try it.
Yes, sir.
So I can give you the right suggestion how to you prepare. Okay. Yeah. Ashish, did you
Yes,
get?
sir.
Yeah. Are you doing?
Sir, actually, I don't know about the Mux synchronizer, sir. I'm not able to recall the figure.
Okay, you don't know about the Mux synchronizer. Okay, if do you know about the time boring, what is the time boring in static timing analysis?
Yes, sir.
What is the time
Time,
boring?
sir, it is a concept in which, instead of using a flip flop in between two flip flops, we uses latch so that the
So what is the latch? You are saying that we are using latch.
Sir, we use this because suppose the first flip flop is taking more time for the calculation, and there is some combinational circuit. So the data coming to flip flop B is taking some time than the clock time. So then, if we use the latch, then since it is a level triggered, then on the level the data can be sampled and sent to the further flip flops as well. So there is some time borrowing at the path ending at the latch. Sir, was I clear or I should answer again?
Partially you are correct, but not fully. Okay, do you know how about the what is time? Do you know about the pipelining concept? What is the pipelining?
Yes, sir. Sir, pipeline is a concept in which means we divide a process in many threads, and we execute one threads at a time, and this at that moment the other thread is
That is
also
parallelism.
Sir, pipelining is a concept in which we execute different processes.
You tell me parallelism. Parallelism created the threads. Okay. Pipelining is something different. Okay.
Sir, can I draw this diagram, timing diagram?
Okay, just do one thing. Like I'm giving you one sequence, 1 0, 1
yes,
0. Okay,
Yes, sir.
Draw the
Yes, sir.
sequence diagram, like state diagram of sequence detector. Okay,
Okay, sir. Yes, sir.
1010. Okay, for Sumit,
Yes, sir.
yeah, okay, your answer is not right, right. Okay, so I am giving you one sequence. Okay,
Hmm.
1001. Okay, draw the
Yes.
sequence detector for this. Okay,
Okay, sir.
okay. Hello, Prasad. Can you tell me
Sir,
what is the object?
the UVM based, right?
Yeah, you know UVM now also. Sorry,
Yes, sir. Yes, sir. You
yeah,
may
yeah, you know
proceed.
UVM. Okay, okay. What is the transaction sequence? What is this
Transactions.
sequence? Yeah.
Yeah. So yes, yes, sir. Transactions will be basically what from the history, but whereas it's a like inbuilt one, but in the sequence item will be extended from the transaction. It is a like transaction. We can say it's like a kind of parent, where the sequence item will be it's also extended one, like we would say like childhood.
Okay, okay, okay. So in the verification environment of UVM, we
Yeah.
have one agent. Okay.
Yes,
So
yes.
agent
Okay.
is which classes are in consist by agent?
Actually, agent we can have we have if we choose two we have active agent and passive agent. If we choose the active agent, we have like a sequencer, monitor, and driver. Whereas if we choose the passive agent, we can have only monitor.
Oh, oh. Okay. So score bit is the part of agent or not?
So which one? Agent only, sir. In the sense I'm telling like we have kind of choosing two types of agent like depends on our application, active agent or passive agent. In the sense I'm telling like that.
Okay, okay.
It is under the agent only, sir.
Okay, so can you tell me the method so that I can
Yeah.
send the data to driver? How can I send the data to driver from sequence to driver?
Yeah, we have like handshaking mechanism by making the port of connection of TLM port.
Okay, TLM port. So can you
TLM port
explain
we
more
had these
than
are bidirectional,
how?
so we can interchange
So
the
so so
information from sequencer to
yeah, yeah. Tell
driver.
me about the all types of TLM method.
Sorry,
Like
your voice is like striking, sir.
okay, maybe this just because of like because of a network issue. So tell me about the TLM port, like how many TLM port we have and how the work is going in TLM port, like how we connect the TLM port and all.
Yes, sir.
Gate
Actually, we
operation,
have
gate operation, put operation, and
yes, sir. Sir,
yeah.
basically, so we are getting the information from the sequence. That sequence is like a object. So it is like it is not a component. So we have to connecting to the sequencer by making the M sequencer handle, M sequencer P sequencer handle. There we can get the information from the sequence, and here it is a sequencer, and sequencer is acting as a routing. Inside we have like FIFO. Uh, there it will be like put implement TLM put and put TLM for like export here like
So
by,
if we have a producer and I have one consumer.
yes sir, one for initializer, one we can say one for initializer,
No,
one for producer.
okay, no. I have one producer and one consumer, and inside the producer I have sub producer. Okay,
Okay.
so how can we connect this? Okay, just
Okay.
draw the diagram and
Yes,
tell
yes,
me
yes,
that
yes,
how.
yes. Okay.
Yeah. Um, okay, so Asif, I think you have seen me the.
Yes, sir.
Okay, just wait.
Sir, this is for non-overlapping, sir.
Hmm. So you draw from the media machine. So
Yes, sir.
first we get
VLSI.
random transit and we get 0 and we get 1. Okay, draw for the overlapping.
Okay, sir.
Yes, sir.
Yeah, number it's okay. Okay. So something that you know, what is the what is the combination circuit and sequential circuit? What is the difference between combination circuit and sequential circuit? Just write. Try to write 5 points. Combination circuit and sequential circuit. What is
Yes.
the difference between these two circuits? Okay. Hello, Sumit.
Yes, sir.
You have sent my answer or not? Yeah,
Yes, yes, sir. Yes, sir. Thank you.
Part time doing 1 0 0 1. Yes, 1. Okay, draw for the overlapping. You draw it for
Okay, sir.
overlapping.
Okay. Sir, is it for, it's only for overlapping also now?
You draw for overlapping.
So it's for overlapping.
It's for overlapping. Okay, in S2, okay, I get 1
Okay.
0, and if again I get 0, then I go to this. Okay, if again. That's okay. Okay. So, Sumit, your
Yes, sir.
poetry logic is not okay. So, can you tell me what is the object in system Verilog?
Object in system Verilog.
Yeah.
So objects are like variables that we define in system Verilog.
Yeah, like data type.
Okay. Yeah, data type, for example, in
Okay, okay, okay. You have to, what is the constructor?
constructor.
Yeah, constructor. Tell me about the constructor.
No idea, sir.
You have no system Verilog and don't have the idea about the constructor.
Sir, I need to revise it. I have not revised for the interview. It's my first interview, basically.
Okay, okay, okay. No issue. Please, whatever you have written in your resume, write it and don't mention anything which you have not gone through. Okay. If you
Okay,
are
sir.
not
Okay, sir.
comfortable, just remove from your resume.
Okay, sir.
Okay. So these are concepts from the OOPS object-oriented programming. You have to know about. Have you guys know about computer organization and architecture?
Yes, a little bit.
Little bit. So you know about boot multiplier.
Boot multiplier. No, sir.
Also. Okay, you know about Harvard architecture and von Neumann architecture?
Harvard and Newman architecture.
Okay. Okay, what is the difference between RISC processor and CISC processor? You know?
Yes, sir.
Ashish, you know the RISC processor and CISC processor? What is the difference
No,
between
sir.
RISC processor? You don't know about it. And Prasad,
No,
you
sir.
know about what is the RISC processor and CISC processor?
I am aware, but I haven't recalled. I need to recall that.
Okay, okay. So, okay. Question. Just give me 1 minute. Actually, I don't know how you guys are preparing for interview. Okay.
Sir, I have idea about responses architecture.
Risk consistent architecture. Just tell me what is the risk consist.
Sir, RISC architecture stands for reduced instruction set, and CISC stands for complex instruction sets. In CISC, the the more emphasized side is on the hardware, but in risk architecture, the software part is maximally used to get the instructions from the CPU and all.
बट कुछ भी मत बोलो यार,
Yeah.
कुछ भी मत बोलो, ऐसा मत करना इंटरव्यू में. Okay, so Ashish, I know from you that why NMOS is preferred over PMOS.
Yes, sir. Sir, basically the mobility of the electron is greater than the mobility of the proton. That's why we use NMOS, since in channel the NMOS is NMOS is like transferred. That's why, because of the mobility.
Okay, okay, so you have this question. Okay. So tell me that how like gray coding is used for the power design. Help us to reduce the power. Gray coding instead of binary coding.
Sir, in binary coding, if we have incrementing something, then the number of bits change can be 2 or 3. But in gray encoding, the number of bits will change just by one single bit. So, and we know that in a CMOS, if the value of the transistor is changing, then there would be some dynamic power consumption. So, just using a gray encoding, since a single one bit is changing, so activity factor get decreases and thus reducing the dynamic power.
Okay. So draw a 4-bit ring counter for me.
4-bit, sir, for me.
Yeah. No. I want from you that draw a 4-bit ring counter.
Yes, sir.
Take a paper.
Yes, sir.
Draw a 4-bit ring counter and write the logic in very code for that. Okay. Hello, Sumit.
Yes, sir.
Hello, Sumit. Maybe he's not.
Sir,
Hello,
hello.
Prashant. Yeah, Sumit.
Yes, sir.
Actually,
Yes, sir. Yes, sir.
can you draw a 4-bit ring counter and write the very low code for that?
4-bit ring counter and Verilog code for that. Okay, sir.
Yeah.
I can draw the diagram, sir, but not the code. I have not gone through it.
Okay.
Like
So,
I have not
okay,
practiced it.
can you write logic for mux?
For mux.
Yes, why not very low?
Yeah, sure.
Yeah, right. Okay, hello, Prashant.
Sir, I'm audible. Yes.
Yeah. So can you tell me the reporting mechanism in UVM? How many reporting mechanism we have in UVM?
So for that we have like verbosity and servosity. We have like a servosity, severity. Severity we have like low, medium, high, debugging. It is like based off hierarchy based. If we like in that we have like a default, medium is the default. Where the like verbosity is like, sorry, I said reverse. Verbosity, these are the verbosity. Where the severity is for importance purpose. This verbosity is used for a filter purpose.
I'm not asking about the verbosity. I'm asking about the reporting mechanism. Like UVM info and
Yes. Info
UVM
warning. Yes.
warning, error, and fatal.
Fatal. Yes.
I'm asking.
Yes. If you like UVM fatal, if we go, it can display and it will count. Whereas UVM fatal will be UVM display and exit. UVM warning will be like only UVM display. UVM info for it is like display and count. Counting the number of sequences.
Okay, I think your verbosity we have like UVM, none, low, medium, high.
Yes. For filtration purpose. Sir.
Yeah, for filtration purpose we have the verbosity. Like,
Yes. Whereas the servosity is like it's like importance purpose. Is as per is like this.
So Can you tell me the environment,
Yes,
like the
that
whole,
like verbosity is for like
whole
like
verification environment which we have for the UVM? Can you give me a verification environment for UVM? Can you draw a block diagram for that?
sure. Okay, one
And
second.
can you tell me that how can we change the severity of the macros in UVM?
Macros like set we have like set methods, right?
How can we can change the severity of macros? Set report.
Sorry, that yes, like set verbosity.
Yes, severity that.
Yes, sir. Set verbosity we have like methods, right? Like methods we gone through that we can get, sir. By changing that we can get the like changes. Here we can get the changes by using this method. Like we have like set arbitration, right? In the same way we have like here. You ask for
Can
environment,
you,
right?
okay, okay. So, Sumit, can you write this in one line?
In one line.
Yeah. One like as one then question mark then.
Yes, sir.
Yeah. Prasad, can you tell me about the changing associated action of macros? Like how can we change the associated action with of macros?
Like we have like UVM do we have UVM do it will randomization within constraints also we
Associated
can.
action like
Sir,
to take action, display, log.
yes. Actually, I'm not getting your question, sir.
Like action okay, if you're not getting, then I can move to another question. What is the quit count and UVM error?
Sometimes your voice is too low, sir.
Not audible. Hello. Okay, no issue.
Yes, sir.
Yeah.
No, it's fine.
Yeah.
Fine.
So can you tell me, we have like a dynamic and a static component in UVM.
Yes.
So which component are
Yes.
static and which component are dynamic in UVM?
Yes. Like where all sequence objects are dynamic, where the components are semi-static, like in the sense quasi-static. Components all are the component static. Where the sequence is a dynamic type. Sequence transactions, these are the dynamic type. The remaining all are the components like sequence or monitor driver. All these are the components. Comes under like semi-quasi, like a transient type, right? This will be always changes. Am I right?
Yeah.
We never say it like static. It's like a quasi-static. Hello.
Yeah. Okay, I'm listening. Don't worry. So can you talk about the field macros? How many field macros we have included, and how can we do print, and what is the core method for record, copy, compare, create, clone, and pack and pack. So do you field macros like
Yes, UVM macros. UVM utils, right? We have with the utils we have to within the utils into utils UVM as per that syntax I forgot actually.
okay, you forgot the syntax for.
Yes.
Okay. You need as I can see, you are focusing on the IPs. Maybe in companies, you are working on the particular IPs. Okay.
ITs, yes.
Yeah, particular IPs. So you have the knowledge within the IPs, but I can suggest you will focus on generic information. Okay. if you are going to give
Okay.
an interview, then they are not focusing only on one particular IP. They will ask different aspect of everything. Okay. So
Okay.
also try to improve your system Verilog. Yeah, are you comfortable in system Verilog also or not? Maybe I forgot.
Yes, system, of course.
Okay. Of course you. Okay, can you tell me like how I2Cs work?
How?
Okay. Can you draw the diagram of I2C?
Sir, your voice.
Very generic diagram. Hello.
Sir, can you repeat again?
Okay. Just 1 minute. Okay, check the chat box. I have written the I2C diagram. Okay, can you draw the I2C diagram of I2C and take a pen paper? Okay.
Okay, in the sense like how like master and slave, right? Interaction.
How can our master and slave relation, right?
Oh, sure.
Yeah, Ashish.
Yes, sir.
Ashish, like just 1 minute. Yeah, 1, 2, 3. So can you give me the definition of pipelining? I can understand what you have written. I know, but can you give me the definition for that?
Yes, sir. I'm lacking in that. Sir, pipelining is a concept in which the different processes are being executed in the subsequent clocks at a time. Sir, for the definition and explanation part,
while fetching the next instruction,
Yes, sir.
the next instruction while executing the first instruction, we can fetch the next instruction. This is the pipelining. Okay.
Yes, sir.
So and can you have completed the digital? Okay. So FIFO. Okay.
Yes, sir.
So FIFO.
Sir, I do also basic idea of system Verilog as well.
Basic idea of system.
Yes,
so
sir.
we can discuss some other day. Okay.
Yes, sir.
Just draw the circuit, draw a circuit diagram for clock gating. What is the clock gating and how can it save the power, and how can it goes from the different modes like supervisory mode and low power mode and low power mode and power mode on. Then how can it work? Just draw a diagram and send me. Then after that you can tell me the concept behind it. Hello, Namrata.
Hello, sir.
Okay, sir.
Yeah, it's okay. Yeah.
Sir, for clock getting, I have to make this diagram, and sir, you have said something. Actually,
No.
the voice breaks.
Just only the what is the circuit, like which gate we have used for the clock gating and how it works. Not more
Sir,
than that.
we will use OR gate, sir.
OR gate for clock gating.
Yes, sir.
If we use OR gate, then every time it will on now. Whatever input we
sir,
are
yes, sir.
giving,
It will be on every time, but it will not switch from 1 0 and 0 to 1. It will be like on every time. And yes, sir, we can use OR gate.
Are you sure? I'm not. I don't know. Can you tell me how many Sumit and for Sumit and you?
Sir.
I'm giving one question in the chat box. Okay, there is
Yes,
two
sir.
questions. And tell me that what everyone for first one begin and end has, then A is equal to B, then has C is equal to A. Okay, then begin and end A has 5. What they are indicating? Okay.
Yes, sir.
Okay, Namrata. Hello, Namrata.
Yes, sir.
Yeah. Okay. For in last year, so dawn and start slowly. Okay. So don't be in a hurry and I can cover everything over one night. Okay. You have to have the patience and start everything very slowly and do things step by step. Okay. Don't be in a hurry. First complete the C programming, then come to digital, then after very long. Okay. After then maybe STSCGC, clock domain crossing, ARM7, RISC-V, whatever
So
you
what I
can
have
do.
to do with the code?
Like what these code are indicating and when we prefer which one and what is the meaning of
Yes,
that delays.
yes, sir. The both one is intra and another is inter delay.
Yeah.
In the first one, the output, the display for the A is equals to will be shown after 5 seconds. But in second one, the value of A
Yeah.
will be updated by.
Sumit,
Yes, sir.
okay, continue that I'm listening.
Yes, sir.
I will give the feedback at the end.
Yes, sir. At the first code, the value of A will be displayed after first second. But in the second code, the value of B, which will be assigned to A, will take 5 second delay. After this, value of A will be assigned to A. And at the first code, the value of A will be displayed after 5 seconds. 5 second delay.
Can you write the what is the meaning of this first line? Like has 5 is equal to B and has A is equal has 5B.
Yes, sir.
Just write it very clear and send me. Okay.
Okay.
So Namrata,
Yes, sir.
start very low, then digital, then system very low, and all things. Go slowly and don't be in hurry. And slowly you will feel that you should understand each and everything. Okay. Other than that, like whatever you have studied, just do proper revision. Okay. Make a strong your digital and see. Then do the do the basic C programming. Okay. Basic, not in very depth. Then move to the very low. Okay. And what other courses you have studied in your BTech curriculum?
Triple sir.
No, courses like
In VLSI for all.
no, in college or BTech. Oh.
Normal electrical and electronics.
Okay. So you have studied like machines, solar, and all things.
Yes, sir.
Right?
Yes,
Okay. So no issue. Just complete your BTech absolutely. So and okay. So Ashish, I recommend you that done computer architecture and organization. Okay.
Yes, sir.
It is very important for the industry. If you don't know computer architecture and organization, then theoretical knowledge is not good. If you don't know how the machine is work and how computer is work, you can only understand how computers are doing the computer organization architecture syllabus. Okay. And Prasad,
Yeah, sir.
so
So
you
I
have
can
sent me.
start.
Have you
Yes,
sent
yes.
me that? Okay.
See, it's like I would say like this is like about SDA is like a serial data, like it's a bidirectional type, and SCL is a serial clock. It is a clock signal, and ITC is like a serial communication. Of course, it is a half duplex communication, and it is a synchronous based communication also. And these are like a two wire. These only two. It has only two wires, and it will support like a multi-master, multi-slave here. And it is advantage is like with acknowledgement, it's like information will be acknowledgement by the master to slave in every time, whereas acknowledgement is given by the slave, and master always initiate the transactions, and which will choose the whether sending or receiving. It will be given by acknowledgement given by slave only, and it will support the 128 address. Like I would say, like it depends on baud rate. So like I would say like processor within the start and stop bit only the transaction will be fulfilled here. I would say like in the start bit, like in the initially we have like pull up register internally. So by that it will be master always it should be high only initially.
So how can data synchronize with in I2C? How can
Like
data is synchronized from like a master to slave and
with the clocks with the SDA, right? It is like a synchronous with the clock signal. But SDA is like a bidirectional.
okay, how handling like how is the your baud rate and clock frequency decide? Like how can you decide
I,
that baud rate frequency for the I2C?
it depends on the its capacitance.
Okay, okay.
Like
So
how much it.
means you have borrows like you have buy your IP of I2C from third party or you have developed it in your own from.
We have taken from the third party. It's like a ODC company or it's a ODC.
Okay, okay, okay. So as I can say that only master can generate the clock and clock will transfer to the slave. Okay.
Yes, sir.
Yeah, okay, okay. If suppose it is age like a clock is working at the age of positive or negative age, okay, then bit is transferred. Then bit is like how you can
Yes,
change this
yes. I
bit
would say.
yeah.
Okay, okay. I would say like master to like how like information will be like carried by master to slave
Yeah,
once once like start bit will be started by the master. It will be initiated by the master. It will be like start bit. It will be high initially. Initially SDA is high. Then it should be like logic 1 to logic 0 with a synchronous with the clock. There like start bit will be started. It will be 0. Like it will be initiate the I will be starting here, and it will be choose the address. If we have the multiple masters, then we can go with the arbitration type. So if we choose by
Which
arbitration,
which type of arbitration?
so in the sense like in
No,
the sense like it depends on.
I don't know what arbitration. Like which algorithm you have to use for the arbitration? Like where you have used round robin security scheduling or something like. What is the concept of arbitration?
Round robin only. I think we are like based on like a weighted based on the address based right? Weightage.
Okay, okay. Continue.
Yes, sir. Like the if we have the multiple masters, then we can choose by sequencer means it will send the some address to the all the systems. And will send the respective slave. Then it will select. Then it will send the it will choose the address. Then it will be select the read and write. It will be a master. If we like going with the write, it should be 0. If we going with the read, it should be 1 bit 1. Then it will send the acknowledgement. Then the master will slave will be send the acknowledgement. Then here I am ready to receive the data. You can send me the data. Then it will be tell like then master will send the data to the slave. Then after receiving the slave, it also send back the acknowledgement to the master. Then the master will be terminate the transactions by making the stop bit.
So are you going to send like in form of packet or just throwing the data toward the master slave?
Form of bit by bit only, right? Bits through only.
You send in form of packet or like bit by bit just send? And so you have to send a packet now. First you have to make the packet of like a knowledge.
Yes. Yes. Packet through only we can send.
Okay, so how can you send the packet? Like how do you the packet is complete and it is packet of like it the actually
the
you
last
have
bit of the
you have the variable data now 1 to 8 bit. So if
yes.
bit is like 6, then how your like your packet will know that it consists of only 8 bit of data, like 6 bit of data instead of 8 bit. Then how can it do that?
By like it will be
Like how can
so it will be
how can you
sorry
that the packet is consists 6 bit?
So you're asking like how like slave will be considering as a last bit, right?
No,
Hello?
so slave will about the packet is consisting of 6 bits
This much
instead
of
of
data,
8.
right?
And yeah, this
Uh,
much of data. How slave will know?
much of like how much of data master will be sending, right?
Yeah, yeah.
Okay. Mm. Oh, okay.
Or if it will say it can send in form of pack structure like only 8-bit data of it can send like pack data means aligned data. Every time it will send only 8
Yes,
8
yes.
bit or maybe
Mm.
it will if you have less bit then it may be do some adding to
Five
make
also.
those bit.
Yes,
Yeah,
sometimes
what is the
bits
concept?
also lost.
So I don't know, but
Like
I want to know
we
from
have
you that actually I don't work on this
uh,
IP, but I have some
okay.
idea about it, not in depth.
But in that case, we
Is
use
that
like clock stretching, right?
clock stitches?
In that case, we use yes, yes. In the sense like we have like ABB, AHB like ready rate. In the same way here like
Okay,
clock
okay.
stretching by making the S clock as a 0, then it will be like some wait state. It should be like holding state.
Okay, okay. Let's assume between a master and slave, one of my bit is updated. Then how can there is an we can retrieve that bit? We can check at the slave side that I have bit 1, and it will corrupted due
Hmm.
to some electromagnetic signal in between the transferring of the from master
Okay,
to slave. Then how it is there any way in I2C to recheck that confirm that this is the which I have sent, or just we have to assume that this is the bit that is coming
by
from the
making the
master.
like so from the slave we can get the like negative acknowledgement. So I didn't get receive the proper data here from the master. Then it will be send the some acknowledgement like a negative acknowledgement. That means in NAC signal. In a
So how it can know that how acknowledgement is done?
like in the register bit have in the like slave, of course slave it will be memory, right?
Select is it is memory. Yeah, okay, okay. It maybe have some fee for registers so that it can
Uh-huh.
contain the data. Maybe. Yeah.
So here like some particular registers there we use some register. Actually in the registers are
So
many are there.
I want to know about a parity bit and error checking. You know
Yes,
about
yes, CRC type.
parity,
CRC.
CRC on parity bit like even and not parity. So is there is I2C is doing these type of thing to confirm
Mm-hmm.
that this is the right bit or not.
But after asking your like ask for one question, right? I can get some raising questions. So yeah, in case like by making the some transaction,
Laptop.
the middle of the bit will be last. Then it will be what will be happen. Even I too don't know that thing. Need to analyze.
Okay. Okay, okay. If you get the answer, then ping me in my WhatsApp. Okay.
Definitely, definitely. I had some raise up questions.
Yeah, yeah. And also I need to know that you just taking only one sample of a between one clock cycle to know that this is
Ah,
the and give the confirmation to this is the one the bit is
yes, sir.
one
Yes,
or
yes, yes,
zero.
yes.
So other
Hmm.
than that, are you taking the multiple sample after that you are going to confirm that this is the
Mm-hmm.
that bit or not? Okay, if
Actually,
you know these questions, then ping me. Maybe
definitely.
just because of you
Basically,
have
basically,
yeah.
actually, we did like gone through like only like one bit, what one, data two, data three. Like it only we will send from master to slave. We
So
cannot like. Mhm.
only taking one sample you get the confirmation that that is the right bit.
Hmm.
Maybe sometimes there is a glitch and you are you
Of course,
may
yes,
be
yes. It may rise.
I believe that they will take multiple samples then only confirm that
Yes,
this
yes.
is the right.
By tomorrow, I will definitely I will approach you.
Okay, okay. Ping me and we will talk on that.
Sure, sure, sir.
Okay, okay. So Sumit and Ashish,
Yes, sir.
Yes, sir.
did you send me the answer?
Yes, sir, I have WhatsApped you.
Okay, in this case, value of will be updated at 0 second and wait for. Okay, okay, your answer is right. And okay, so Sumit and Ashish, you are on right track. And Sumit, you have completed this, like you are doing master first year on or like final year?
Final year, sir.
Final year. Okay, for final year, like you have to do more work. Okay, so
Yes.
so include risk processor in your resume. As I can say, it is not there,
Okay.
and synchronous FIFO. Okay,
Okay.
and maybe do some one verification of project related to one verification of system Verilog. Okay,
Yes.
so it will help you. Okay,
Okay, sure, sir.
so and you do encryption and decryption. If I will get some other day, then I will go in the deep of encryption and decryption, how it will work. Okay.
Yes.
And other than that, the terminology which you have used, like this will done, this will done, this is not going to create a good impact on the interviewer. Okay, just say like first it will assign the value of B is assigned to A, then it will wait, then execute. Okay, then it will going to assign the value. Okay, not like that, this will done then after. Don't use this type of terminology. Okay,
Okay, sure, sir.
okay, so it is okay. And other than that, include the risk 5 and synchronous FIFO in your resume. Maybe traffic light controller also a good project, but risk 5 is very important for you.
Okay,
Okay, just because of you are going to take the off-campus placement, so learn the computer architecture also.
sir.
Okay,
Okay, sir.
every company needs the computer architecture and go deep inside of the computer architecture. Okay, hello Ashish.
Yes, sir.
Yeah, so you are in final year of BTech, no?
Yes, sir.
Have you got placed offer from any company or not?
Yes, sir. Sir, I got a offer, but means I was doing internship, but I resigned from there.
Okay, from where you get the offer? Like from hardware company or from some software company?
No, sir. It was hardware company in Bangalore, Elders
Which
Technologies.
one? Okay, okay, don't need to be hurry. Just complete your internship, then you will get the multiple offer.
Sir, I resigned
Okay.
from there.
Just complete the internship. Who told give you the suggestion to resign it?
Sir,
Internship
actually,
is
the
must
work
then
culture.
work
Sir,
culture. Yeah,
sir,
yeah,
like I was assigned as a design engineer. Means,
yeah.
but the work I was getting was to anything like sometime embedded, sometimes some to create some documents. So I thought that I'm not learning that much, so I resigned from there. And the work culture was also not good.
Actually, the startup is like that only. Okay, they will give you any work, and you can learn a lot of things from there. Maybe just completed your internship, then you will add the experience of internship in your resume. Then you will get some other opportunity also.
So I have done only
Maybe
2 months internship there.
okay, at least complete 6 months, then they will offer you to give some certification. It will help you. Okay, no issue. You are on right track. Don't regret whatever done you have to.
Yes, sir.
Smart people don't regret on any action. Okay.
Yes, sir.
Just completed risk 5 processor and computer architecture. Other thing are okay with you. Okay, learn the
Yes.
computer architecture. It is must.
Sir,
Okay, sir.
sir, one question
Yeah.
for, like I'm asking like, sir, have you
Yeah.
gone through like PCI like protocol? Like working, are you working on PCI?
No, actually I haven't worked on the PCI, but I know about like I have the documentation. If you want, then I can send you. Okay,
Just ping me, sir. Just yes, sir.
okay, okay, I will
Because
send you
rather
the document.
see everyone like every rather than asking like these Amba basics are everyone choosing the PCI only. Interview
Yes,
point of
PCI
view.
and PCI and SATA is two
Ha,
major protocol which are used for the SSD. Okay,
yes, yes.
yeah,
But in the
actually
in the in
people
the outside we
prefer.
cannot be. Hmm. In the whereas
Okay,
like in the internship part we didn't get any like coding type like PCI. We can get only Amba based. In the real time only we have to working on the PC. So without working on that, we cannot get any
Okay,
idea.
for working in PCI, you have to like set a very good setup, and the multi-dollar billion companies can only afford this.
That's
Okay.
so
Yeah.
I like
So
I
if you
attended like 2-3 companies.
yeah.
I just got selected in the like some other company, but I rejected. But because like due to CTC like some negotiations, they would like suggesting always a PCI protocol only. I just know just basics, but I haven't gone through
I have
deeply. So if you would,
I have only I have the documentation. I will send you. Okay. Other
just
than
ping me,
that,
sir.
if you
Okay.
want to learn of the PCI, so I can give you some GitHub the repositories. Okay. So
Okay.
gone through that, and you will have some basic idea. Maybe that help you.
Okay. So ping me, of course.
Okay.
I will
And
go through that.
hello, Namrata.
Yes, sir.
Okay, Namrata, I will suggest you some lectures only. Strictly follow those lecture and get connected with the register. And if you need any help, then ping me anytime. Okay, and this is for all of you. If you just save my number. If you have stuck anywhere, I have like I know I have experience in each and every field almost. Okay, whatever things you have getting and you are not able to understand, just ping me, and I will let you know that what are the answer and what is the suggestion. If I am not able to give you the correct suggestion, so I will connect you with the right person also. Okay, so if you have any question, then ask me.
Okay.
Otherwise we can end the meeting. Yeah, Sumit, why are you very silent and being very sincere?
No, sir.
Uh, ju-
Yes, I am trying to analyze the subjects that I need to work on.
Yeah, just this is my sincere suggestion. If you are not able to understand the programming of Verilog and system Verilog, just do C programming first, and the part of like how function will work, structure array, and after that just move to the Verilog and learn digital. Then first learn digital, okay, combinational circuit, and do the Verilog programming of combinational circuit. Then sequential circuit, do the Verilog programming of sequential circuit. Okay, slowly you will move. Don't think that it will happen over one night. Okay, you have to spend some time, and then only you can learn the approach. Okay, and other than that, except Prasad, everyone do RISC-V processor, and other than that, traffic light controller and the FIFO. Okay. After that, in skills, you will know Verilog, system Verilog, and C programming. Okay. And for other concept like ST and CDC, enough. Okay. So these are all enough for creating a good resume and taking a good impact. Okay. Try to speak every time how the work is done. Okay, and ask some. If you and other than that, when you have completed, I will share some questions also which help you to improve your and skills. Okay.
Okay, sure.
You have any other question?
No, sir.
Anyone? Okay, then so we are going to end this meeting. Okay?
Sir, I have one question.
Yeah, please.
Sir, UVM is one of the necessary in verification, but sir, currently I have some only limited to system Verilog. So sir, I am applying for some.
Yeah. So
I am applying for some companies. So will it work?
Just because of
Yeah, I can say like
yeah.
Yes, sir.
Please. Maybe he has good
sir,
experience.
I can say like yes, if you are like good at SVM, then do not to worry like about the UVM. UVM is like all are like inbuilt only. Just gone through basics. Base theoretically, it's enough.
Yeah. Okay. I want to add some other thing. Actually, if you are doing master, then they will treat you as a fresher, and then they will not expecting system Verilog in on campus. In off campus, they will accept that you should know about the system Verilog. But UVM, I don't think at BTech level they will expect from you that you should know about the UVM. Okay, so if you are just learn the OOPS, then move to the system Verilog. and do some basic one project like FIFO or D flip-flop. If you are not getting that how to do the project, I will give you the project, okay, whole project, and you just need to understand that. If you are not able to understand, then ping me, I will explain you. Okay.
Yeah, okay, sir. Thank you, sir.
Yeah. So
Thank you very much.
Right now, Rajat,
yeah, sure.
then just I have to talk to you about like Rajat sir.
Yeah.
Hello, Rajat is there?
Maybe you can call him later and he will.
Definitely.
Answer.
Okay, I will approach her later.
Okay, good night, everyone. Bye bye.
Okay,
Yeah, thank you.
Thank you,
Sir,
sir.
can you like ping me that PCA protocol, sir?
Yeah, I will. Just ping me, I will send you. Okay.
Yeah, sure.
Bye.
Definitely. Thank you.